This is Chapter 2. This is the introduction to Chapter 2 for the AP Physics C. And we're just going to take a look at what is physics, and in particular what we're going to study in this chapter. One purpose of physics is to study the motion of objects, how fast they move, for example, and how far they move in a given amount of time. In this chapter, we study the basic physics of motion, where the object moves along a single axis. Such motion is called one-dimensional motion. In future chapters, we will look at two-dimensional motion and as well as three-dimensional motion. Motion along a straight line is what we're going to look at in particular. 2-3 talks about position and displacement. And we're going to start off with this. Position and displacement are really two different terms. Our position is where we are at a certain instant, and displacement is how far we have traveled in a certain direction. When we change from one place, call it x1, to another place, position, x2, that is called displacement, and that's delta x. If we were to write that out in an equation, it would look just like this. Delta x is the x2 minus x1. So we have a person starting here at position x1. They walk along here until they get to this position. Let's say they move to here. x2. x2 minus x1, that's delta x. So this is delta x. This is our change in displacement between those two positions. Now, position is all relative to your starting point. So when I say you can start at a position of -2, you can start at a position of 0, you can start at a position of positive, and then your displacement is just measured from that point. If you move to the left, it's a negative direction. If you move to the right, it's a positive direction. And again, your position is just your starting point. And if we move off in this direction, let's say we move right to here, our delta x, in this case, would be a -2. Because we would have taken our x2 minus our x1. Because remember, when you do delta x, it's always the final position minus the initial position. x2 minus x1 is just 0 minus 2. And so that's how we end up with -2 meters. And that negative sign stands for the direction that we're traveling. If it was reversed, it would have been positive 2 meters. And that positive would have been the direction we were traveling. That's how we call it displacement. We're going to look at these two terms, displacement versus distance. And displacement is how far we've traveled in a certain direction. And distance is just the distance we have traveled. And there's some key ideas here that we need to know. We want to know what is the difference between displacement and distance. Displacement is a vector, and distance is a scalar, and again, that vector means it has direction. Displacement is a measurement from start to finish, where distance measures total distance traveled. So our example that we have to think about here is if we travel 3 meters up and 4 meters left, we have to realize that our distance is 7 meters, but our displacement is 5 meters at some angle. And if we were to measure that angle here, if we were to figure out what that, come up here and we figure out what this angle is right here, we'd have to say what that angle is. And in this case here, it's at an angle of, opposite the 4 meters would be at an angle of 53 degrees. From that north line, it would be 53 degrees from the north line. So you add 90 to it actually to get that whole angle. But what I'm just going to say here is 53 degrees. It's really west of the north line. This is west of the north line. So, and I think you probably remember that from last year. Just a review. So now we're just going to check your understanding. Here are 3 pairs of initial and final positions respectively along an x-axis. Which pairs give a negative displacement? So I want you, so for example, A would be You start at negative 3 meters, you go to positive 5 meters. So in that case right there, that'd be a positive 8 meters. If you think of your number line, here's your negative 3, here's your positive 5. You start here, you end over here, so that means you moved in the positive direction. Your delta x equal a positive 8 meters. So do the rest of them, do B and C, and see what you come up with for your answers. Pause the video. So hopefully you end up with an answer of this right here. The answer is B and C because B is a negative 4 meter displacement and C is a negative 10 meter displacement. So to wrap up what we've learned here so far, we start out learning about motion. In our first chapter, position and displacement allows us to understand motion, and displacement is a vector and distance is a scalar. This last sentence is one of the bigger ideas of this chapter, or this section of this chapter. So again, as one final example, if you travel here, then here, then here, then here, then here, then here, your distances is all these distances all added up, but your displacement is always from where you start over to where you finish. So the red line is the displacement. The black line would be the distance traveled. Displacement, remember, has the direction. The distance does not.